Demonstration OFISP failover spanning tree protocol port security active directory group policy object file server file encryption.
Good day everyone. This is the demonstration of ISP failover and balancing of our project. So the first one, we assume that this ISP1 is the on-verge and this ISP2 is the PLDT. So to see how this ISP failover balancing works, we need to access the FortiGate dashboard. So let's go to our browser, then type the IP address 192.168.100.10. Just wait, then log in the username and password of the FortiGate. Then as you can see here, this is the dashboard of FortiGate firewall. Then we go to the network, then SD1. Just load, just wait. Then here in the SD1 interface, you will see how FortiGate firewall balance the bandwidth speed given by both internet connection. So here in this SD1 usage, the blue one is the converge and the yellow one is the PLDT. The PLDT give a 1% bandwidth speed, meaning the PLDT have a slow internet connection. So the FortiGate firewall balance the internet connection given to a network. As you can see here, almost everything in the internet connection given to a network is converged. So we can assume that the converge take over all the internet connection speed. In the upstream, the converge, the downstream converge na nasa 9%, 95%, and 5% of PLDT. Then we will see here for the volume, just the same volume. Then sessions, 93% for the converge, 7% for the PLDT. So it's still balanced. FortiGate balance the internet connection given to a network. So we go to the SD1 rules. Here in the SD1 rules, you will see the load balancing algorithm, wherein 75% of the internet connection given to a network is converged, and the 25% is the PLDT. Meaning, even though that the PLDT has a slow connection, there is a converge to fulfill this low internet connection given by the PLDT. So the FortiGate firewall will balance the speed of internet connection given to a network. So in the other scenario, in the failover, we go to the SD1. Here, as you can see, the PLDT was taken in charge in the internet connection, meaning the converge has no internet connection. We assume that the converge has a maintenance in their site. That's the beauty of having a 2 ISP provider. You will not have a uninterrupted service of internet connection. That's the failover and the balancing of ISP.
So now we are going to demonstrate the spanning tree protocol. So spanning tree protocol is a network protocol that eliminates infinite looping inside an redundant network. So now in here for this demonstration, we have the console for the main switch 2, and end user, and on the right side of the screen it is a work chart application for the first floor switch going to the main floor switch in here, and below is the Wireshark for the first floor switch going to the main switch 2. So let's go to the main switch console and see the spanning tree protocol configuration. So as you can see on the screen, it is indicated that this is the root bridge, which means that this switch is the main switch that is elected from the spanning tree. So all the data packets from the local area network will go to this switch. So as you can see on its interfaces, So it's all forwarding status. So now let's go to the main switch 2 and compare the spanning tree protocol. So as you can see here on the main switch 2 console, there is an indicator that this is the root bridge because this is the secondary elected spanning tree switch, which means that if the main switch fails, this main switch 2 will take over for the data packets. So as you can see in its interfaces, it has a status of block because it detects that the main switch is functional. So to eliminate the infinite looping inside this network, so the secondary switch block the redundant port. So now let's go test the spanning tree protocol by going to the end user console. So let's type DHCP. So okay, now we successfully gained an IP address from the firewall. So now let's go to the Wireshark of the first pair switch, going to the main switch to see the DHCP request. Allow me to scroll to find the request. Oh, here we go. Here. So as you can see, we have here the result of the DHCP request. So from the unknown source, which is the end user, it requests an DHCP request from the firewall, and then the firewall respond from this IP address. This IP address is from the VLAN gateway of the first pair switch. So the DHCP request has been acknowledged. This is what it indicates here. So as you can see here on the first pair switch going to the main switch 2, there are no DHCP requests packets that has gone through this link. So now let's shut down the main switch to test if the spanning tree is working. So I'll just shut down the ports of this main switch. Shut down. So okay, we successfully shut down the ports of the main switch just to represent that it is down. So let's go to the main switch 2 and show the spanning tree again to see its forwarding interface status. So as you can see, it's now in forwarding mode, unlike before that it is blocking in here, and now it's in forwarding mode, which means that it detects that the main switch 1 is malfunctioning, so it takes over to the data packet. So now let's try to gain an IP address again from the end user console. There. So okay, now we successfully gained again an IP address from the firewall, and now as you can see here on the second Wireshark from first pair switch going to the main switch 2, we can see the request of the end user here, just like on the Wireshark 1, but instead of going to the Wireshark 1 or this main switch connection, it goes to the main switch 2 packets. So there we go. We successfully implemented a spanning tree protocol inside this redundant network. So thank you. So next we are going to demonstrate port security on access switches. So let's start the end user PC and go to console. Okay. Then let's go to the console also of its respective access switch. So okay, let's proceed to test the port security. Then let's go to the end user console and type IP DHCP. That way it is requesting for a IP from the firewall from its respective VLAN. So as you can see, we successfully gained an IP address and there's no changes in the access switch configuration. So let's stop the end user PC and disconnect it to the port where it's connected. Let's connect the unknown PC to that port. So okay. So let's start the unknown PC. Then let's go to console and let's acquire IP DHCP 2. So okay, IP DHCP. So let's wait for it to finish acquiring. So let's see if the unknown PC actually acquires a IP. So as you can see, it doesn't acquire IP from the firewall. It's because the port has been shut down on the access switch, and it's because of the port security violation, which means that the MAC address on the access switch does not match the MAC address of the unknown PC. So let's stop the unknown PC and reconnect the end user to its respective port. Okay, so connect again. There we go. Then let's start the end user PC. Then we go to console and reconnect the end user. Then let's go to first floor switch. Then we need to manually shut down and shut down the ports, because of in that way we can gain IP address again from the firewall. So okay, the port has been up, so let's acquire IP DHCP again from the end user. So okay, let's try. So as you can see, it cannot obtain an IP DHCP server because the access switch is running its MAC address. So let's test it again. So this is the last IP testing we're gonna do. So as you can see, it obtains an IP address again from the firewall. Then therefore we conclude that we successfully implement a port security on access switches to protect the network from unauthorized access. Thank you.
In this demonstration, we're going to add users to Active Directory. Go to Tools, click Active Directory Users and Computers. And here, under Planning Department, so we're gonna right click New User. This is going to be a sample user. We'll fill it out with a sample client. For the first name is sample and the last name will be client. This is going to be a sample user. So we'll fill it out. After that, we can have our local name as SC client. A simple reminder here, as we're going into different environments, that local names can be completely different. It really depends on how the organizations want to set up their usernames. So you could have your first initial, last name, or your first name. It really depends. There's a different ways that you can do, but as long as you keep your structure the same, it should be fine. We're just going to do the next step. Set up a password. We want to make sure that the user must finish the password. But here, it is okay because this is a sample user and everything else can be unchecked. We're going to do the next and we're gonna finish. Under our planning department, we now have a sample client here. We're going to log in to the S client. So there you have it. It is to set up different users within Active Directory. Now, as we start getting into the policy, more security groups can start to enter our environment. Let's proceed to the next demonstration. Here in group policy object, it is already created under the domain, which are the IT department and planning department. Here in IT department, it is already enabled the restriction that cannot change the IP address. There are several group policies already created. This will be a sample to the test if it is working. Here in prohibit access to control panel, it is already enabled, and also the remote task manager. Now we're going to log into the user of planning development to test if the control panel is not working. As you can see, the start task manager is not available or cannot access. We're going to search the control panel. As a result, users cannot be able to start control panel or PC settings or run any of their items. So, as you can see, there's a message appears explaining that a setting prevents the action. Now, let's try the other group policy in IT department. Here, we're going to open a network and sharing center. If you enable this setting, it cannot be enabled or configured by administrators. As you can see here, there needs to be login details of the domain to access or to change the network. Thank you.
Good day everyone, I will demonstrate to you how file server works. So a file server is a central server instance wherein it enables clients to access server storage capacities. So what I'm going to show you here is who have access to who. So as you can see, I have Ppsc file server. I'm going to select it. So as you can see, I have created 3 folders. These are the departments, shared folders, the IT department, and also the planning department. So what I'm going to show you is who can access the file and the level of permission being implemented. So I will try to view the IT department. I will select properties and then check the security to see the permission access and who has access to who. So we have here system administrator, IT department group, and administration. So they have full control, and the other one is read and execute. So they have different access. Wherein full controls allows user to read and write, change, and delete files, while the read and execute allows users to view and run executable file, including scripts. These are folders. So now I'm going to look inside the IT department. As you can see, I have 2 folders here, which is the Ppsc IT and the staff folder. So we will see who has access to who. Can the staff access the Ppsc IT, or we will see if the staff can access the Ppsc IT folder, or they have privilege in accessing the Ppsc IT folder. So what I'm going to do now is I'm going to log in as a staff to check what privileges are given to an employee. So I will try to log in my credentials. So this is an example of a staff. So I will try to log in my credentials. So I'm logged in as a staff in the company. So what we're going to do now is to see what privileges do I have as a staff employee. So I'm going to check the IT department and see what's inside. Let's see what's inside. So as you can see, I only have here the staff folder, wherein I can create file or folder, I can edit it, and I can execute it. So I'm going to create a folder, and I'm going to name it as a more testing. And as a staff, I can create folder inside the staff folder. So let's try if I have the privilege to delete my folder. So delete. So yes. So as you can see, I have privilege in deleting the folder inside the staff folder. So what I'm going to do now is to close, and then I'm going to switch the user into Charlene Sako, and let's see what privileges the Charlene have or the head chief have. I'm going to log in my credentials. So I have logged in as a chief. So now what I'm going to do is I'm going to see what privileges are in it for the head. So I'm gonna choose IT department and look, we'll see what's inside. So as you can see, as a head admin, I have access to the chief CCIT together with the staff folder. So yeah, that's how file server works. I'm gonna perform file encryption. So file encryption is a way of encoding files, including the sensitive data they contain, in order to send them securely. So what I'm gonna do now is I'm gonna create a file. So new text document. So I'm gonna name it sample. Then I'm gonna encrypt it by choosing right click, properties, and then advanced, encrypt secure data. Okay. Then apply, then encrypt the file only. Okay. So now let's try to put it in the IT department folder, specifically in the staff folder. So to check if the client to check if the client have access to this file. So now what we're gonna do is we're going to open this file using the client. So let's go to Windows. Let's go to the client. So IT department. So the staff folder. As you can see, here's the encrypted file, which is sample. So we're gonna open it. So it is it is access denied, meaning the file is encrypted. So now let's try to create a file here in the client. So sample2. So let's try to encrypt this file also. So advanced, encrypt to secure data, apply, then encrypt file only. Okay, and okay. So let's try to upload this file in the staff folder. So it is already encrypted. Now let's go to the Windows server if the server does have access to the encrypted file. So as you can see, sample2 is encrypted. So now let's try to open the file. Now that's sample1. So there you have it. So that's how you perform file encryption. So the purpose of this is to prevent malicious attackers or to encrypt the data we're in, to protect your data or your file itself. So there you have it. Thank you so much.